Greetings once again from Department of Clinical Microbiology at AIIMS Mangalgiri. And as most of you would have known that this year's M100 document, that is the 33rd edition, has got many changes over here. And what we will be attempting would be to describe and explain in details what these changes are, because many of these changes have got very strong and very deep clinical impact, and that's why what is the rationale behind these changes, that is what we'll try to explain through this video. So this will be taken by myself and my friend and colleague Dr. Devrat Das, who are been formally trained by the CLSI for this particular live update. There are some disclaimers and declarations that the intended audience are clinical microbiologists, clinicians and ID physicians who understand the basic concepts and breakpoints about the MICs. As I said, both have been formally attended a CLSI webinars on these changes, and CLSI has expressed the actual technicalities why these changes have been brought about. And until unless we don't understand why these changes, the reason behind these changes have been made in this 33rd edition, only then we can understand what the outcomes are going to be. So we are going to discuss only the clinically significant changes, and the rationale will be discussed over here. Some extra bonus that we want to discuss, which may not have been discussed in other forums, is like the basic PK/PD will be discussed, because many of the changes which are brought about, especially the aminoglycosides and the Priscillin tazobactam, they strongly depend on what the PK/PD aspects have to be understood. What are the certain basic parameters, certain definitions that should be understood before we delve into these changes. Some significant and important questions, few of them will be discussed in the post-session question and answer round of this particular CLSI webinar, and what 2024 holds for the next year for the M100 document. What are the likely changes that will be brought to this particular document? We don't have any financial interest, and we have our own legitimate copy of our M100, which has been owned by Dr. Devrat himself. So these are the disclaimers and the declarations. So what is the main change that has happened in the M100 document is the appearance, how it looks like. That is the main change, because so far we have been looking at certain particular format and we are so used to that. So now what they've done in the 33rd edition is to change the entire appearance, and that is the most evident change, because since 1972, almost 50 years, as claimed by CLSI, there have been no changes. There have been only 3 tables in the table 1, that is 1A to 1C. Till 2022, there have been only 3 tables, but now many new antimicrobials have been added, many new mechanisms of antibiotic resistance have been there, and there is an increased prevalence of the MDR infections. So that is why, and because there has been a lot of emphasis and there are requirements for the AMS programs, for the accreditation which is required for these AMS programs. So these changes must be highlighted and must be implemented in the labs as soon as possible. As you can see that the number of tables have increased, the number of table 1 have increased from 3 to 16. So earlier they were just 1A, 1B and 1C, but now they are from 1A to 1P. Then there has been segregation of antibiotics, which has been shifted from groups A, B and C to now as tiers 1, 2 and 3. Primarily, these tiers have been made to make your antibiotic panels and to help or support in cascade reporting. And the table 1, that is table 1A, B, 1A, 1B and 1C, which was earlier vertical, has now gone horizontal. I'll just show you what it means, right? So this is what our table 1A, 1B and 1C was in 2022. As you can see, the table 1A was for non-fastidious organisms, table 1B was for fastidious organisms, table 1C was for anaerobic organisms. Now there are 16 tables from 1A to 1P, and that has highlighted all these organisms separately. Earlier there were just 4 groups, that is Enterovactralis, Pseudomonas aeruginosa, Staphylococcus aureus and Enterococcus. So there was only 4 groups earlier, but now we have got 16 groups and they have been tabulated separately, and every table has got its own set of clinical rules and clinical footnotes. So as you can see that Salmonella and Shigella has been separated out of Enterovactralis and been put into a separate table. So that is something very interesting. So this is how 2022 document used to appear as. There was a vertical, there was a top to bottom arrangement of group A, group B, group C and group D, and of course there was a separate group for urine, that's group U was there, and we had 4 groups like this. So we used to go from top to bottom, that is the vertical format. Now this is 2023 edition 33rd, and we have gone from left to right in the horizontal format from tier 1, tier 2, tier 3 and tier 4. So now it has been divided tier wise, primarily meant for the how to make your panels. So what earlier were groups A, B and C have now been divided into 4 tiers, tier 1, tier 2, tier 3 and tier 4, and we always have had this urine group separately, and so that is why, and the group investigational has been kept the same the way it was earlier, others has been kept the same way, and IA also been kept same. So as you can see, this table 1A for example is for Enterobacterales. It is specifically saying it is not including inducible AMC producers and Salmonella and Shigella. So that is one very classical bracket that they have put up. You have to see this thing very carefully as to what are the antibiotics which have to be put up for Enterobacterales and exclude out the AMC producers, Salmonella and Shigella. So this is the tiered system that they have made, that is tier 1, tier 2, tier 3 and tier 4. If we compare it with the groups which were present earlier in 2022, so group A classically corresponds to group for tier 1. So basically it includes all the basic drugs, includes the agents appropriate for inclusion in the routine primary testing panel as well as for routine reporting. So basically group A or tier 1 remains the same. They basically contains they test for routine drugs and you report the routine drugs. In group B, it includes the agents that may warrant primary testing. So basically what we are doing is they are appropriate for routine and primary testing, but they may or may not be reported depending on the cascading rules established at every institution. So cascading rules we have to establish at our institute. So we test them routinely, but we may report by a cascading method. Let's jump to group C, that earlier used to say that includes alternative or supplemental antimicrobial agents that may require testing in those institutions that harbor endemic or epidemic strains. So basically group C corresponds same as tier 4. Basically they are the antimicrobial agents that may warrant testing and reporting by clinician on request. So these are on request. Like for example, colistin in Enterobacterales, we are not routinely putting up colistin because that is, we don't have any breakpoints available for that. They are not the interpretive criteria we don't have for colistin right now. We don't have a gold standard which is easily implementable also. So that is why this is one example for colistin I can do. So like for example in tier 1 we are putting up 3rd generation cephalosporins for our Enterobacterales. In tier 2 meropenem in Enterobacterales. Tier 3, so these are the antibiotics that may be tested routinely based on the institutional specific guidelines or by clinician request. So it is somewhere between, you can say, tier between B and C. They have put up another tier or as tier 3, which are the agents which are appropriate for routine and primary testing in institutions that serve patients at high risk for MDROs, but should only be reported following cascading rules. So you can put these antibiotics in your routine, or you can put it on request depending on what is the overall antibiogram pattern of your institute, and of course do the cascade reporting on them. So this is basically your tier 1, tier 2, tier 3 and tier 4, which is clearly given for all the different group of bugs from table 1A to table 1P, that is table 1. Now coming to our next is the selective reporting or the cascade reporting. So now earlier the cascade reporting and selective reporting was not clearly highlighted by your M100 document, but now it has been clearly highlighted. What is this document about? So first of all, the major flaw is that what we should override the concept of the first line and the second line drug concept. That is wrong. So many people, what they do, they have got a set of, let's say, 10 antibiotics. So if it is resistant to all, then they'll put it on that subset of that resistant organism, the next set of antibiotics, what we call as the second line. So when we are calculating our antimicrobial, the cumulative antibiogram, when it is being calculated, then it becomes a total skew in your data. So you should not put up additional set of antibiotics on a subset of of the resistant isolate, because your data will get skewed. And if you are doing so, then you have to release the antibiogram only against that subset of the isolates. Like for example, if you are testing for colistin only against the carbapenem resistant enterobacterialis, in that case you cannot report colistin susceptibility for all the enterobacterialis. You have to go in only for that specific subset of the gram negatives. Then we have to test across all the tiers of antibiotics, include all the antibiotics should include in the cumulative antibiogram, and report by cascading or selective reporting only. Now this was supported by CDC document in August 2020. If you just Google CDC August 2020 cascade reporting, you will find the document. Then of course last year we had the M39 document, for which one masterclass was already done, in which they also specifically highlighted about the cascade reporting, and this year by the M100 33rd edition. So cascade and selective reporting are mandatory requirements for AMS practices to encourage the appropriate antibiotic use and control the emergence of AMR. So what is selective reporting? Selective reporting is you report specific antibiotics even in your raw data also, and which are effective clinically. That means there's information, or there are numerous footnotes in M100 which tell you which antibiotic to report and which not to report in certain set of bugs, certain sites, certain specific samples. Like the M100 document in the appendix B clearly highlights what is the intrinsic resistance, which is a very exhaustive, which is we are not discussing right now, as per the patient and specific site information, and at times antibiogram specific. Like for example, we don't report vancomycin for MSSA. If we specifically talk about the CLSI definitions, CLSI specifically say that reporting the results for specific antimicrobial agents based on defined criteria unrelated to results obtained from the AST. So irrespective if it is showing that if it is amikacin or gentamicin is susceptible for Salmonella typhi, we don't report because we know it is intrinsically resistant, and that is what is mentioned in the CLSI also. So the organism ID, the body site, clinical setting, or patient demographic, considering all these things, we have to do the selective reporting. Like for example, nitrofurantoin is only reported in isolates from urine for lower UTI, as it is only effective in the treatment of uncomplicated lower UTI caused by urease negative organisms, because we know that nitrofurantoin does not work in a high pH or an alkaline pH, which is created by the urease positive organisms. Similarly, same thing I mentioned for aminoglycosides for Salmonella typhi also. So these are few examples which will guide you about the selective reporting, other than the intrinsic reporting, which you have to see the appendix B. Few examples, like for blood, we don't report tigecycline because of its high volume of distribution, because it immediately, the moment we administer the drug, it immediately gets inside the tissues, skin and soft tissues. So that's why it's a drug of choice for skin and soft tissue infections and complicated intra-abdominal infections. For CSF, again it is specifically mentioned in the earlier table 1B. This is the earlier, older table 1B, that first generation, second generation cephalosporins and all the drugs should not be given in CSF. Similarly, we have got a long list of examples which have to report, which are not to be reported for certain specific patients or specific specimens, and few examples of antibiotics which have to be reported for specific sites only. Like tigecycline, if you are not reporting for blood, it is only meant for complicated skin and soft tissue infections and intra-abdominal infections only. Nitrofurantoin, phosphomycin, so all their role is specified. So you must know that where the antibiotic is not to be given, not just the bug but also the site also. When it comes to cascade reporting involves reporting results for specific agents based on the overall AST pattern. So the results for the secondary or the broad spectrum agents, which are like the, for example, tier 2 drugs or the tier 3 drugs, are only reported if the isolate is resistant to the primary or the narrow spectrum agent, which are the tier 1 drugs. So, or in the same class of drugs. For example, in the same class you might have the second generation cephalosporins and the carbapenems also. In that case also you can do it. So we can do the inter-tier and intra-tier reporting, cascading we can do. So again, it is very important to note that the resistant results, now this is very clear, the resistant result for a broad spectrum agent should always be reported even if the organism is susceptible to a narrower spectrum agent. We have very commonly seen that ceftriaxone we see susceptible and imipenem is resistant. So the mechanism of resistance is not the beta-lactamases, it is the porin loss or the efflux mechanisms are there, which are not. So that's the common trend. We think that if it is resistant to a third generation cephalosporin, it will be resistant to it will be susceptible to a carbapenem and not vice versa. So there are exceptions like this when the mechanism of resistance is not to the beta-lactamases. In that case, we have to know and confirm that this is the definitive resistance mechanism. So then only we should report like that. And cascade rules can be created for agents within the same tier or between the tiers. So as I said, in the intra-tier and the inter-tier, we can do the cascade rules can be done, and these are depending on your institution. So agents listed in the same row between the tiers in the table 1A and 1P can be used as a guide for creating the cascade reporting rules. So they are just guiding documents. Ultimately, the cascade reporting has to be followed at your institution level. Like for example, if we say that cefotaxime or ceftriaxone, that is third generation cephalosporin tier 1 Enterobacterialis, if it is resistant, then we report cefpime. If cefpime is resistant, then we can go in for ertapenem and meropenem. So it is the inter-tier and the intra-tier cascading can be done accordingly. So this is an example of the inter-tier and the intra-tier reporting can be done. Now it comes to beta-lactamases. This is also something very interesting that CLSI has done this time, is that they have broken their silence on the AMC beta-lactamases this time. So what they have done is that IDSA released a specific treatment protocols for the AMC producing Enterobacterialis this last year in 2022, which specifically said about that AMC beta-lactamases are extremely heterogeneous group of beta-lactamases, and there is no single uniform method to have its detection. So CLSI is still quiet on the detection method for the AMC beta-lactamase, but it does mention in table 1A in footnotes B and C, it takes the cognizance of 8 organisms which are known to produce the beta-lactamase enzymes, the AMC beta-lactamases, namely Citrobacter frundi, Enterobacter cloacae, Hafnia alvei, Klebsiella aerogenes, Morganella morgani, Providentia, Serratia marcescens, and Yersinia enterocolytica. In comment number 25, if you see in table 2A, it also cautions that the resistance during therapy with the third generation cephalosporin is likely to de-repress the AMC beta-lactamase and create a resistance to higher set of the beta-lactams like your carbapenems and even your BLBL combinations, and this is especially seen in Citrobacter frundi, Enterobacter cloacae, and Klebsiella aerogenes. Now there are two separate footnotes. One is table 1A, footnote B and C. Then we have got table 2A, comment number 25. So in comment number 25, you can see they have mentioned only the 3 bugs. They have not mentioned the other 5 bugs over here. So what they say is that the risk of AMC de-repression during the treatment is moderate to high with Enterobacter cloacae, Citrobacter frundi, and Klebsiella aerogenes only, and even though low in number but clinically significant for Hafnia alvei and Yersinia enterocolytica. Therefore, the acronym that was earlier known as SPICE or SPACE have now been re-acronymized as the HEC-yes, which is a new acronym for the chromosomal AMC beta-lactamase producers, where we have got H as the Hafnia, E as Enterobacter cloacae, C as Citrobacter frundi, K as Klebsiella aerogenes, and yes as the Yersinia enterocolytica. So for antibiotic naive, the HEC-yes bugs, whenever the cefpime, which is the drug of choice, whenever the MIC is less than 2, or in case of CLSI, or less than 1 in case of UCAS, because UCAS is normally much more sensitive and much more considerate when it comes to the resistance, so they are more careful, and they normally their MIC values are slightly lesser, or maybe 1 dilution lesser than CLSI. So if the cefpime MIC is 2 or 1 for UCAS, then in that case cefpime is a drug of choice, and that must be included in the testing panel of the for the Enterobacterialis. That's in the tier 2, which is normally in tier 2. Cefpime is in the tier 2 in Enterobacterialis, but when it comes to the HEC-yes organisms, it should be kept in the tier 1. Now, what does CLSI say on ESBLs and carbapenomases? So, until 2022, CLSI had advocated that only you need to test ESBLs for epidemiological reasons. There is no need to test for the clinical purpose. But in 2023, they probably considered the outcomes of the Merino trial and they found that ESBL testing is necessary because in that case, you have to avoid the piperacillin tazobactam and going for the carbapenem group of drugs. So that is why IDSA treatment also is guided by the laboratory reporting and with presume or ESBL producer. So IDSA also recommend the lab must test for ESBL producer and they have to routinely report it so that the antibiotic can be changed from the BL-BLA combination to a carbapenem. So in 2023, CLSI considered the view of the AMS team to test and report the ESBLs with genotypic and phenotypic tests so as to guide the therapeutic management. So this is and the elevated what about carbapenemases? Whenever the carbapenem MICs are increased or the zone size diameters are decreased, then CLSI also warrants the same thing for the carbapenemase also, because in that case we have to see whether it is a metal dependent carbapenemase, it's a MBL or a non-MBL carbapenemase. So accordingly the treatment will also change. So for these genotypic and phenotypic tests, the details are provided in tables 3B, 3C and Appendix H. So what does the CLSI ultimately say? That for why to test? Basically for not just for infection prevention and control, but also to guide the appropriate antimicrobial chemotherapy, antimicrobial therapy, and to avoid piperacillin tazobactam monotherapy. Maybe if it is low inoculant infection, you may try piptazo along with another synergistic drug like an aminoglycoside, but normally you must avoid it as a monotherapy, especially in the high inoculant infections. And it is specifically, as before, only for E. coli, Klebsiella pneumoniae, and Proteus mirabilis. And you can use appropriate third generation cephalosporins as the surrogate screening agents depending on what is the most prevalent ESBL in your region. In India, most of them are the CTX-M kind of ESBLs. So normally what we use is either cefotaxime or ceftriaxone as the ESBL screening third generation cephalosporins. When it comes to carbapenemase, same thing for infection control purpose, for health, public health advisory, and to guide the appropriate antimicrobial therapy depending on the type of carbapenemases. And we have also designed multiple templates that we have discussed during our workshop in February this year with our participants, how to make different templates for the detection of the carbapenemase and the type of carbapenemases which are expressed on the GNBs. And when it comes to the AMC Beta-Lactamases, yes, they have expressed their concern about AMC Beta-Lactamases, but CLSI does not provide any standard tests available for the AMC detection, but they do tell you that you can always go in for the based on the identification of the Heck organisms, third generation cephalosporin results may be suppressed. So because third generation cephalosporins are the good inducers and the good the substrates also for the AMC Beta-Lactamases, so that is why they must be avoided in your AST reports. Now comes to the critical part, the breakpoints, which have changed in the CLSI M100 33rd edition, and we will start this part with the explanation of the PKPD concepts, and then it will be taken over by regarding aminoglycoside. Dr. Devrat will talk about this also. So what should we introspect when it comes to antibiotics? So whether it achieves clinically significant concentration levels at the site of infection, the bug, dose, frequency and the site is fine, but what about the PKPD target? What is the PKPD target and what is the percentage of target attainment, that is PTA? So until unless these two concepts are not clear to us, why these changes were made will not also be clear. So are the breakpoints near to the epidemiological cutoffs? What is the epidemiological cutoff? That also we just briefly talk about. How to keep an eye on the MIC creep. Are the clinical breakpoints being achieved at non-toxic dosing concentrations? Then is the nursing staff administering the antibiotic following the are they following the proper right antibiotic posology? Are they following the right sequence of giving the antibiotic? Are they giving the antibiotic in particular dose in that particular infusion or extended infusion or continuous infusion? That also is very important. And is the antibiotic being given to the patient is inducing resistance or not? So which is why we mentioned in the previous slide that the third generation cephalosporins are very dangerous for the Heck organisms because they are the chromosomal AMC Beta-Lactamases, and they will induce the resistance. And will loading doses help in such cases or not? So few basic things about breakpoints is that the breakpoints are dynamic endpoints. That means they are dynamic numbers, they keep on changing over time, and depending on what kind of organisms we are dealing with. So breakpoints are nothing but their values that separate populations of bacteria. So what is breakpoints? There are different type of breakpoints depending on what are the value and what are the kind of bug we are looking at. If we are looking at the pan-susceptible isolates, or those isolates which do not harbor any resistance mechanisms, they are the wild type strains. In that case, the breakpoints are the epidemiological cutoffs breakpoints, or the wild type breakpoints for isolates which exhibit no acquired resistance. These are the wild type phenotypes. So those who are using wild type, if you see, sometimes you will get the MIC levels as 0.25 or 0.125, and they're showing an arrow towards left, and if you click on that, the phenotypic type, you'll see it's a wild phenotype for that particular antibiotic, for that particular bug. So that means the MIC values are so low that it is towards the wild type breakpoint range. Then we have the clinical breakpoints for isolates exhibiting which have some form of acquired resistance. They are the clinical breakpoints. And then the PK/PD breakpoints for isolates with partial resistance, where the dose and duration can be altered. And when these breakpoints are validated, this particular MICs are validated against a particular dose, and they have proven treatment. So that case, they are known as the susceptible dose dependent, which is the CLSI term. And when they are not validated, they just use the normal dose and the high dose as specified by susceptible increased exposure. This is the word, this is the term that is used by UCAS. So UCAS is not validating each and every MIC against a particular dose, against a particular treatment outcome. They just say that this is the normal dose, this is the SIE dose, or the susceptible with increased exposure. So bacterial isolates with the MICs above the epidemiological cutoffs, they normally have some form of acquired or mutational resistance mechanisms. The epidemiological cutoffs, this distinguishes the wild type phenotypes from the non-wild types. So like for example, the ATCC strains are the genetically stable, they are the wild type strains. And one thing that we must keep in mind, that you should not extrapolate your wild type or the epidemiological cutoffs to your clinical cutoff. So let's say for Gentamicin, we don't have any breakpoint zones. For Acinetobacter, we only have got MICs, so we can't pick up the Gentamicin breakpoint zones from the ATCC strains. So it's like that. So we should not, because ATCC are basically ECOF strains only. Then breakpoints are determined by CLSI each year, and they utilize information like clinical and microbiological data for clinical isolates, and therefore they are the clinical breakpoints. So they have got three breakpoints: the epidemiological breakpoints, the clinical breakpoints, and the PK/PD breakpoints. This is just an example just to show you that this is the lowest MICs. Normally it corresponds to the upper limit of the epidemiological cutoff ranges. So the lowest limit of the, let's say if you got 100 or 120 strains, and the lowest MIC distribution curves, that represents the upper limit of the epidemiological cutoff range. So how does the CLSI reviews the breakpoints? It is done mainly through this particular document known as the CLSI M23, because there is continual research, there is development of new resistance patterns are there are variations in the epidemiological cutoffs. The baseline level of the epidemiological cutoffs also keeps on changing. Normally it remains stable, but over time, for the past many years, they were either not evaluated properly or they have actually changed. We don't really know, but whatever results that are coming out from continuous research, we find out, we do clinical trials, and we see new resistance mechanisms, and then the new data comes, then the breakpoints are reassessed, and these breakpoints are accepted by the CLSI ad hoc working groups. They put forth their data, they discuss, they deliberate in their CLSI meetings, and they think whether they have to reduce the breakpoint concentrations or increase the dose, and then they submit the data to FDA, US FDA, where they are either recognized or not recognized by FDA, and only after the recognition by the FDA they are implemented into the commercial AST systems, which most of us are using right now, and then that gets implemented by the lab. So this is a particular slide that is, I would like to give the credit to Dr. Romney Humphreys from CLSI for this particular slide. So the breakpoints are available on the best available knowledge at the time that the breakpoints are set. So at that particular time, what was the current resistance mechanisms, what are the current drug dosings, what is the current knowledge of the PK/PD. So because most of the drugs, unfortunately, for a long time have not been assessed, and that includes the aminoglycosides also, and which is one of the reasons why aminoglycosides, after the serious assessment of the past 5-6 years, especially by UCAST and by the US CAST, the ECOFs were re-evaluated and it was found that they have to be revised. So that's why the aminoglycosides have had a major revision this year. So this is the point where the labs have to adopt the off-label validation over here. So like for example, a few years ago when colistin susceptibility testing and interpretive criteria was changed from susceptible to intermediate or non-interpretable, so that time most of the technical staff, they came to your machines, they changed and put a particular comment. So that is that is not approved by the FDA, but then that is the off-label validation which is done at the level of the labs only. So the ECOFs, they determine the baseline level and they also decide the intrinsic resistance. So with a wild type strain having a very high MIC is intrinsically resistant. So you will see a pan susceptible Proteus will be pan resistant to nitrofurantoin also. And ideally the upper range of the ECOFs, as I mentioned in the previous slide, the upper range of the epidemiological cutoff, that is the wild type isolates, should be ideally lesser or lower than the should be lesser or at the lower range of the clinical breakpoint, which is the non-wild type. So practically there is always some form of overlap, but only for a very small number of isolates. When this overlap increases, then unfortunately at that particular MIC, the doses have to be adjusted accordingly. So similarly, we had the adjustment of doses for aminoglycosides. CLSI still says 15 mg per kg body weight for amikacin, whereas UCAS says 25 to 30 mg per kg body weight at that particular MIC, same MIC for amikacin. So either for that, but if we can't lower the MICs, because that will come into the wild type range, so we have to keep the MIC same and then increase the dose of the antibiotic. So the intrinsic resistance, it does not develop overnight, it develops over years or over centuries. Like for example, Pseudomonas aeruginosa always had a chromosomal AMC Beta-Lactamases, and MIC creeps and all these things, they are all happening at a epidemiological cutoff values levels. So and we have never, like I said, we have never evaluated in detail, as most of them are giving combination therapies only. So we have not evaluated individual treatment profiles also. So there has been always a gradual change which is invariably permanent. So resetting the breakpoints by the M23 document, whenever the strains are found to be less susceptible, there is a slight rise in the breakpoints. Epidemiological breakpoints are also higher than what were earlier were detected. Then in that case, you have to consider the re-evaluation or the resetting of the breakpoints. Whenever the organisms are getting a new mechanism of resistance are developing, in that case, new dosage or new formulations of antibiotic agents or new clinical usage may require a change. Like for example, if some of the companies, they want to revise from, let's say, you want to go from 1:1 ratio of a BL-BLA combination to a 2:1 ratio, in that case also the breakpoints have to be revised. So companies just cannot release antibiotics just like today you want to release a 1:1 ratio of a BL-BLA combination, tomorrow we will release a 2:1. So every time the statutory authority like CLSI will ask, if you are releasing from 1:1 to 2:1, then what will be the dose and what MIC and what PTA and what all those things will be asked by the statutory authority, either whether it's CLSI or UCAS or US CAS. So whenever there is a new clinical or pharmacological data that suggests any kind of reassessment is required, action by or any data from the FDA or any of the regulatory authorities which is provided, in that case also we may have to revise the CLSI or the breakpoints. And the CLSI, the changes the CLSI approved reference methods also may have the impact on the interpretive criteria. For example, if I am changing the reference method from broth microdilution to agar dilution, so that will also have some effect on the breakpoints as well. So if you see this particular graph, that one antibiotic is given as a single shot and slowly it falls down, then we have got extended infusion which is given slowly, and then we got continuous infusions. That's a typical graph that we can give an antibiotic in three different types of infusions can be done: intermittent, extended, or the continuous infusion. So if we talk about the PK/PD, every antibiotic has got a pharmacokinetic nature. So either that means what the body will do to a drug and how it behaves inside the body. So on the basis of that, there are three kind of antibiotics. Either they are time-dependent antibiotics or concentration, or they have the property of both the antibiotics like that. Then we have got the PK/PD indices. That means for that particular antibiotic, we have got an index to be defined. So for the concentration or the time-dependent antibiotics, their PK/PD index is the percentage of time that antibiotic remains above the MIC. So for the time-dependent antibiotics, you need to have an increased exposure of the antibiotic above the MIC. So that is what is the percentage of time that antibiotic remains above the MIC. That's the first PK/PD index for the time-dependent antibiotics. Then we have the Cmax to MIC PK/PD index, where it's the concentration that is dependent. So you have a sharp peak in the concentration, then it falls slowly. So that is specifically like for fluoroquinolones or for aminoglycosides. Then there is a PK/PD index that is the total dose given. For example, for vancomycin, we have got a third kind of PK/PD index, that's the area under the curve. Area under the curve means the total amount of antibiotic that is given divided by the MIC. Similarly, we have got a PK/PD target. Now, every PK/PD index is fixed for a particular antibiotic against a particular bug in a particular specimen type. So, if we don't even consider the specimen type, let's say the specimen is blood. So, for that, we have the PK/PD target, it measures the drug efficacy. So, for example, if I say that the piperacin tazobactam has to remain 50% times above the MIC during its dosing, so that means from this dose to this dose, let's say it's 8-hour dosing, so I have to for 4 hours, that is 50% times it should be above the MIC, 50% times above the MIC. So if I am able to reach the concentration and the infusion in such a way that I am able to achieve this entire 50% time of the MIC, that becomes my percentage of target attainment. So if I have got a 100% PTA means 100% times I have been able to maintain a concentration of piperacin tazobactam 50% times above the MIC, 50% of the dosing interval above the MIC. So that is the PTA, the percentage of target attainment. So these are different the different target attainments which are applicable for different antibiotics. For clinical cure, there's a different. For microbiological cure, they are different. So we'll just talk about the clinical cure. This is pretty detailed review article. I can share this link with you later on. But this is a very interesting article by Robert J. et al. From Lancet Infectious Diseases in 2014, where it tells you few examples of what is the target attainment achieved. Again, I'll give you another example. Like for example, this is the different PK/PD dosings and the different dose, different frequency and different infusions. So this first one, the square, is half an hour infusion. So this first one is square. Let's say if this is MIC was 1, 2, 3, 4, 8, 16, 32. So this is the increasing MIC. This is the percentage of target attainment. So how much target I have been able to achieve with that particular antibiotic. So let us say if my dosing is 6 grams per day, or let's say that is total dosing 6 grams per day, 2 grams every 8 hourly, and let's see the different infusions. So if you have an infusion of this square, half an hour infusion, so if you see over here that at an MIC of 8, I am able to achieve only 30% target attainment. So if my MIC is higher and my infusions are slow, infusions are rapid, they are independent infusion, half an hour, 30 minutes infusion, so that means my percentage of target attainment will not be very good. At the same time, the same dose, if I am able to, let's say if I see the circle over here, the circle is our continuous infusion, CIs. So if I am having continuous infusion, so despite having an MIC of 8, I will be able to achieve as high as 95% of the target attainment. So if we are decreasing the infusion time, especially for the time-dependent antibiotics, we are able to improve upon the treatment outcome. Similarly, if we see a dose of 8 gram per day, that is 2 gram every 6 hourly, similar effect is there. If we have slow infusions or continuous infusions or infusions with loading doses, we will be able to see that we have got better percentage of target attainment. So the percentage of target attainment is the ultimate outcome that we need to see whether that antibiotic is able to achieve it or not at a particular dose, at a particular MIC, at a particular dosing interval. So which is why these parameters are very, very important, and these parameters have been taken into account by CLSI this year. They are mentioned last year also, but this time they are more relevant. Similarly, is another example of showing meropenem extended infusions. Let us say the target attainment of carbapenem is 40% times above the MIC. So let us say if the MIC interval is 8 hours, so out of those 8 hours, 40% time the MIC of meropenem should be above the MIC. So if that is my target. That's my target. So if I have to achieve this target of 40% times above the MIC, I can do multiple things. I can do this is a total dose given, and this is how it is given in what time. So if I see this particular blue line, if I see this blue line, this is the lowest. So at a MIC of 1, let's say MIC of 2, I am getting a target attainment of only around 60%, maybe 65% only. So that is 0.5 grams every 8 hourly is a 1 hour infusion. So that's not a very good thing. But at the same time, if I see over here, even at an MIC of 4 for meropenem, MIC of 4, this orange colored line, if you see, 1 gram every 8 hourly as a 3 hour infusion. So if I increase infusion time at 1 gram every 8 hourly, I am able to achieve a very, very high percentage of target attainment. So which is why the infusion times are extremely important when it comes to the beta-lactam antibiotics. This is another example showing same thing. If the same dose, 30-minute infusion every 4 hourly, and 4 hourly infusions every 8 hourly. So you can see that the percentage of target attainment is much higher if we increase the dose as well as the infusion times as well. So now when it comes to piperacin, tazobactam and Pseudomonas aeruginosa, there is a hidden message in our M100 this time that CLSI revised the piperacin tazobactam breakpoints in 2022 for enterobacteriaceae. We all know that from 16 to 8. Now this year, what CLSI has done is that the MIC breakpoints are unchanged. They still remain for Pseudomonas. I am saying Pseudomonas in piperacin tazobactam. So the MIC remains unchanged. That is, it was 16 last year. It is 16 this year also. But the I category that was earlier given a range of 32 to 64, that range has been reduced to one single value of 32, and the resistance was earlier 128, that has been lowered to 64. So UCAS is also determined that the epidemiological cutoff of piperacin tazobactam is 16. Therefore, at this moment, the clinical breakpoints and the epidemiological breakpoints of piperacin tazobactam are equal for Pseudomonas aeruginosa. Now, this is not a very good thing to happen. The clinical breakpoints, if they are falling low, or the ECOFs, they are rising, so if they are overlapping, that's not a very good thing to happen. So, if we see the standard PKPD target for piptazo is 50% of the time it should be of the MIC, and the MICs and the clinical breakpoints are based on a dosage regimen of 4.5 gram every 8 hourly over 30 minutes or 3 hours. Now this is, I have highlighted this, why? Because this is as per CLSI M100 table 2B1 point number 10. So as of this now in 2023, this is what is mentioned in CLSI over here is that at a breakpoint of 16, you can give piperacin tazobactam as 4.5 gram every 6 hourly over 30 minutes or 3 hours as per this particular table. Now this statement is valid only when the MIC is less than or equal to 8 and not 16. Now when the MIC is 16, one may want to follow, because in that case, if the MIC is 16, we'll have to follow what the CLSI did with the Enterobacterialis last year to include the SDD range, which was 4.5 grams every 6 hourly over a 3 hour infusion, or 4.5 gram every 8 hourly over a 4 hour infusion. So this is what is being done over here. So now if you see which are changes in the CLSI piptazo MIC interpretive criteria for Pseudomonas aeruginosa, how the changes have happened over the years is that for almost 10 years the susceptible breakpoint MIC was 64, then for 12 to 22, another 10 years they got it down to as low as 16, so this is 20 years, not 12. So, and this year we got 16, so they have not changed the MICs because then it will come into the epidemiological cutoff range, takeoff range. Whereas, so again the breakpoint, just go to the next slide. So if you see over here very carefully, this is Pseudomonas aeruginosa breakpoints. Piptazo, the breakpoint is 16.4, which is the same as the epidemiological cutoffs. So they say the breakpoints for susceptible are based on dosage regimens of 4.5 gram administered every 6 hourly over 30 minutes or over 3 hours. Breakpoints for intermediate are only to provide a buffer zone to prevent small uncontrolled technical factors from causing major discrepancies or interpretation. So basically something like the SIE. So breakpoint, so 32 means it could be an SIE kind of a system for CLSI. Now same thing happened for in enterobacterials also. So if you see very carefully, it's like breakpoint for SDD. So the SDD ranges, if you see over here, the SDD range of enterobacterial is 16.4 and the susceptible breakpoint range of Pseudomonas is also 16.4. So we cannot equate this OR over here. In that case, we will need to adopt what has been done for enterobacterialis, that at breakpoint MIC of 16.4, we need to have a infusion time of 4.5 grams. If you are giving it 6 hourly, then it has to be 3-hour infusion. If it is 4.5 gram administered every 8 hourly, it has to be a 4-hour infusion. So that is this OR is slightly you can say erroneous or maybe non-interpretable, because when I saw it for the first time that how can 4.5 gram every 6 hourly over 30 minutes can be the same as that of 3 hours, because they are totally different. So if you see this particular table with a PKPD target of, let us say, of which is 50 for Piptazo, the dosing which are cited and not cited under M33 for Pseudomonas aeruginosa. So this is what was mentioned for Pseudomonas aeruginosa in the June rationale document, but this is what is mentioned, that if you are giving at 4.5 grams 6 hourly, 8 hourly, in this case the MIC is 8, then it is valid. This particular infusion time is okay if the MICs are 8, but if the MIC rises to 16, you can't use this OR over here. In that case, you have to follow the same dosing criteria that we do for enterobacterialis at the SDD breakpoint range. So this is one thing that you have to be very careful of. Coming to levofloxacin as a monotherapy for Pseudomonas multifilia. Again, there is evidence that has emerged from the new PKPD data from the in vivo studies and the murine infection models. They found that the FDA breakpoints of there's a huge difference between CLSI and FDA breakpoints of levofloxacin. The CLSI ad hoc working group, they evaluated multiple studies which used the in vivo PKPD models like the murine thigh infection model to evaluate the levofloxacin efficacy of steno. Most of these studies use doses that does not simulate the clinically relevant levofloxacin exposure. So basically, what they are trying to say is that if you are using a 750 milligram per day as a monotherapy for Pseudomonas multifilia at a MIC of 1, in that case, still the percentage of target attainment is only 72%. Again, if you are doing the Monte Carlo simulations, we will find that if you are giving a dose of 750 milligram per day of levofloxacin and the MIC is 0.5, then in that case you can attain a percentage of target attainment of 96%. But if the MIC is 1 with a PTA of only, then in that case only 72% is the chances that you can achieve that particular target for that antibiotic. Now what has happened is that instead of, because right now the MIC is 2, so instead of lowering the MIC breakpoint from 2 to 1, what CLSI decided that instead of lowering the MIC from 2 to 1, let us give the statement not to give levofloxacin as a monotherapy. It may not be helpful, or it will achieve at a breakpoint of 2, it will achieve probably maybe 50% or 40% of PTA will be there. So instead of lowering the breakpoints, he said that levofloxacin should not use as monotherapy in steno, use it as a combination therapy. So even if you lower the breakpoint from 2 to 1, in that case also the percentage of target attainment is only going to be 72% and not 100%. So right now this is the status of the FDA adoption of the CLSI breakpoints. This is again courtesy Dr. Romney Humphreys also. The different antibiotics, the different organisms, whether or not the FDA has recognized them or not, what is the FDA which is offering instead of that, and what is the date of decision. This is just to tell you that what is the process, that for at this moment for what antibiotic against which organism whether FDA is recognizing the CLSI breakpoints or not. So why am I ranting only on FDA only? Because right now in India we don't have any controls over any antibiotics. There is a gross failure of the statutory bodies, including NMC. Yesterday only on 12th, we only witnessed what the NMC document has come out. They have totally kind of abolished or reduced the role of microbiology in the MBBS curriculum. There are every possible BLI which is present and which has been banned, but it is still available for use in India. There is supremacy of pharma industry. This is a classical example of sulfurylsulbactam. Now this is present only in India specific cards and kits only. Sulfurylsulbactam is not used anywhere in the world except for India, just because of this particular reason, because supremacy of the pharma industries and because of certain incentives given to the clinicians. And that is why until unless we don't equate antimicrobials to our antipsychotics, we cannot control AMR. So with this, I'd like to come to the next part of our presentation, which will be presented by Dr. Devrat Das on aminoglycosides in Enteromaterialis and Pseudomonas aeruginosa. Welcome, Dr. Dev.
Thank you, sir. And I will be presenting the aminoglycoside breakpoint changes, and we can say that this year's CLSI change, the essence is PKPD, data and probability of target attainment. So when we talk about that, we need to have to understand the pharmacology, the PKPD data, where whether the drug is there when we choose a breakpoint, whether at that breakpoint the drug which is attaining at the plasma level to kill the bacteria or at least have a bacterial stasis. So to just recapitulate about the aminoglycoside, this is a broad spectrum antibiotics, may be used for gram negative and gram positive both. It acts via 30S ribosome binding and thus inhibiting the protein synthesis of the bacteria. It requires oxygen for its activity, so it is not active against the anaerobes. The common examples are Gentamicin, Tobramycin and Amikacin, that is in use for clinical in many clinical pharmacies. There is also Natilmycin, but it is rarely used, and there is Streptomycin also, which is used in only nowadays reduced to mycobacteria treatment. Now coming to the PKPD data, as Sumit sir have already told, the beta-lactam antibiotics are time dependent, whereas the antibiotics of aminoglycosides are the more concentration dependent, and this type of killing hence known as the concentration or dose dependent killing. And the bactericidal effect of this class of drugs will be achieved if the peak concentration is approximately 8 to 10 times of the MIC. This is needs to be understood, because if we are choosing a breakpoint too higher, then to get 10 times more of that breakpoint, it will be like unachievable in plasma concentration, certainly not in a patient safety and non-toxic doses. So the first published breakpoints for aminoglycoside was back in 1979, and which was continued till 2022, and they were based on MIC distribution available at that time. Susceptible breakpoints were based primarily on blood levels related to the toxicity, and the resistant breakpoint were based on the maximum blood level achieved by this compound. So basically it was more likely that at that time more robust PKPD evaluation was not done, or that facilities were not there like Monte Carlo simulation at that time. So it has had a long time, and the concentration or the breakpoint has been there for almost 50 years. Now, as previously discussed, that the M23 data document of the CLSI have mandates how to change or revise the breakpoints, and certainly this aminoglycoside fulfill this re-evaluation data, that the PKPD data indicated existing breakpoint is now inappropriate. Current doses regimen of aminoglycoside differs substantially from doses regimen used to establish the original breakpoints. Here I would like to mention that earlier the practice was to give aminoglycoside in 2 to 3 doses per day, but due to the toxicity of the aminoglycoside, mostly the nephrotoxicity and the ototoxicity, now the standard practice is to give aminoglycoside once daily dosing. So for that there is a need to change the breakpoint. Now coming to the breakpoint change of the Pseudomonas aeruginosa. To be specific, that gentamicin is now out of the armory. For Pseudomonas aeruginosa, it is intrinsically resistant. Tobramycin susceptibility breakpoint reduced from 4 to 1, that is 2 doubling dilution has been reduced. Amikacin susceptibility, though they have intact breakpoint range at 16 microgram per ml, but it is restricted to urine only isolates. Now, why Genta is intrinsically resistant to Pseudomonas aeruginosa? Again, we have to go to the PKPD data and the probability of target attainment. Now, when we choose the probability of target attainment, we need to first see whether what is the criteria for our probability of target attainment, whether we are choosing a side effect from the drug or a bacterial stasis from the drug, and we have to choose the breakpoint at which we need that probability of target attainment or PTA. So if you see here that this is the triangular part is 1 log reduction from the base level. If we choose the 0.5 data, it is almost 100% PTA. If the sidal effect of gentamicin is to be used for clinical use in Pseudomonas aeruginosa isolates or infection, we need to have a 0.5 MIC or MIC of 0.5 microgram per ml as breakpoint, so to attain the target of 100. But if you see here the bacterial stasis, if we choose, then also it is coming around 1. This is the net bacterial stasis is rounded 1, and at 1 MIC it is nearly 100 or it is around your 96%. So by this we can infer that a pretty low MIC is required or a pretty low breakpoint is required to achieve the bacterial stasis against a Pseudomonas aeruginosa infection. Now coming to the normal wild type distribution of the Pseudomonas aeruginosa, it has been seen that the epidemiological cutoff value is 8. That means that in the nature, whatever the Pseudomonas aeruginosa are present, the normal MIC or the wild type MIC, without acquiring any of the resistance pattern, they have distributed up till 8 microgram per ml. So because these wild types of isolates have more MIC than the clinically achievable 1 microgram per ml, this has been now totally out of the breakpoint susceptibility, and now it is, we can say that the gentamicin is or Pseudomonas aeruginosa is intrinsically resistant to gentamicin. But having said that, the CLSI this year have not included in its intrinsically resistance table about the Pseudomonas aeruginosa and gentamicin, but they have given in the table of 2B that tobramycin susceptibility cannot be used as a susceptibility for gentamicin. Here, this differentiate two things. Many a times when we use this term, and in clinical use also, gentamicin and tobramycin have been used interchangeably. Now this will totally change, because the gentamicin will not attain the serum level or the plasma level to act upon the Pseudomonas aeruginosa, and this needs training and education to the clinician, to the pharmacy, that gentamicin is not a replacement of tobramycin, at least for Pseudomonas aeruginosa. Now coming to the tobramycin breakpoint also, the epidemiological cutoff or ECB of Togra is 2 microgram per ml. Now, as in the previous slide I told that the concentration that needs to be achieved is at least 8 to 10% to have at least 90% of cure rate or the probability of target attainment. The earlier breakpoint, that was 4, which is not achievable if which is there. So if we have that breakpoint in place, this percentage will not be achievable. 8 to 10 times more than MIC will not be achievable for Pseudomonas aeruginosa when tobramycin is concerned. That is why again instead of going for bactericidal effect, the CLSI has taken the net bacterial stasis as the probability of target attainment, and it has reduced the breakpoint from 4 to 1. Now why amikacin changed to for urine only isolates? Same, and the bacteria, instead of bactericidal effect, now the PTA is net bacterial stasis. And I should say here that why they have taken as bacterial stasis as the target attainment, because in most of the comments it has been written that aminoglycoside should not be used as a monotherapy except in certain case of urine infection. For all other infection, it should be used as a combination therapy where the bacterial stasis may be we can agree on that aminoglycoside can be used as an adjunctive therapy rather than a monotherapy. Now coming to the amikacin part, amikacin is highly have high concentration in renal cortex and reach high percentage in urinary excretion as unchanged. So to say it is concentrated in urine. So in case of UTI, mostly in case of cystitis, it can be thought as a treatment option, and most of the time because the expert group or the ad hoc working group did not want to directly remove amikacin from the armory of Pseudomonas aeruginosa infection, they have kept it at urinary isolates only. Now the dose that has been used for amikacin is either 20 milligram or 30 milligram extended interval, or they have tested for traditional doses also. So the probability of target attainment for amikacin with a dose of 20 milligram per kg, which is FDA approved and at the highest level, though it is actually 15 milligram per kg, but the highest dose approved by the FDA is 20 milligram per kg. And if the breakpoint we set at 16, the stasis breakpoint is 0.3%. The stasis breakpoint, not the cider, and the cider is 0 for 1 log reduction of the bacteria, it is not effective at 20 milligram per kg. Now the epidemiological cutoff of amikacin is also 16 microgram per ml. So what is used, that the 2 microgram per ml MIC was considered as a PTA stasis level for 20 milligram per kg once daily dosing. Now if amikacin is to be kept as a option for treatment for Pseudomonas aeruginosa infection, it needs to be lowered 3 doubling dilution from 16 microgram per ml to 2 microgram per ml. Now the peak of is 16, so if we reduce the value or the breakpoint to 2, it is essentially goes through or bisect to the wild type of the isolates or the distribution, wild type distribution, and it eliminates the utility of MIC and utility of testing of MIC as well as the disc diffusion method. Now coming to the aminoglycosides in enterobacterials, though gentamicin has not been removed here, the susceptibility breakpoint reduced from 4 to 2, tobramycin again from 4 to 2, and amikacin from 16 to 4. Now here they have added another aminoglycoside, that is plazomicin, and as I said previously that the additional comment has been added that the aminoglycoside to be used in combination therapy for enterobacterials in case of non-UTI cases only. Now rationale is same with that of the Pseudomonas aeruginosa and the PKPD attainment, that here also net bacterial stasis of PTA is target of interest rather than the bactericidal effect of the aminoglycoside, and the biggest impact will be on amikacin usage because this is one of the most frequently used antibiotic across the hospital. So that will come into play. So if you see here, this has been taken from OFID journal, that percent of probability of amikacin PKPD target attainment by MIC based total drug plasma area under concentration and time curve to MIC ratio, that if the MIC is 2, then the PTA will be around your 92%. That is how it has been decided that it should be changed to 4. But if the 4 microgram MIC is taken, the probability of target attainment reduced to around 23%. So that is why it is always to be used in case as a combination therapy. Now coming to the addition of plazomicin and other aminoglycoside, this is the Sentry data which has been published again in Open Forum Infectious Disease, that when CLE are considered, according to the FDA and CLSI criteria, the plazomicin has a 94% susceptibility. Similarly, the CLSI 2022, if we give for amikacin, it is 75.2%. But if we apply the recent guideline or the recent breakpoint, it is reducing to 52% in case of 59% in case of CRE. Similar things happened for ESBL producer, the aminoglycosides enzyme producers, and MDR and XDR enterobacterial. So in every class of isolates, there is a substantial increase of plazomicin or susceptibility of plazomicin ranging from 94 to 99%, but the amikacin susceptibility has been decreased. So, what is plazomicin? This year the CLSI has come up with the breakpoint. The FDA have already approved its uses since 2018 for complicated UTI, mostly that are caused by E. coli, Klebsiella pneumonia, and Proteus mirabilis. Its activity, as shown in the previous data, that it has activity against ESBL producer as well as the carbapenem resistance enterobacterials. The plazomicin molecule contains a structural modification that makes it stable to hydrolysis by the vast majority of aminoglycoside enzymes. So, it is more useful, at least at this point of time, it is presumed to be more useful rather than the other members of the aminoglycoside family. However, it is to be noted that plazomicin breakpoints do not apply to the Morganellacea family, because here the resistance is mediated due to poor penetration of the aminoglycoside and not aminoglycoside modifying enzyme. So this has to be taken into consideration. Now, what is the problem with the changes? Till now, it is not FDA approved. Since it is not FDA approved, the commercial AST manufacturer may not update the new breakpoints. Even if they have the breakpoint in the test panel, if they have their low dilution, it can be used as off level, but again that has to be validated. And it may so happen that for gentamicin, like it is intrinsically resistant, in future there may not be a panel for there may not be gentamicin in a test panel, because it is intrinsically resistant to Pseudomonas aeruginosa. So either the manufacturer may come up with a different test panel or cassette for Pseudomonas aeruginosa specifically, or they might cut down or remove the gentamicin and add only a tobramycin for a test panel which will be suitable for both enterobacterials as well as Pseudomonas aeruginosa. Now, what can be done? To summarize the aminoglycoside breakpoint changes, that it may be emphasized that the aminoglycoside should only be used in combination therapy. This is a must. And when reported against Pseudomonas aeruginosa, the gentamicin reports should be suppressed. And when reported for urine isolates only, the amikacin only to be given in the AST report and not other specimen. Now this is the comparison of which was earlier in 2022 to reduction in the 2023. So again, to recapitulate, the amikacin enterobacterials breakpoint and tobramycin Pseudomonas breakpoint has been decreased by 2 doubling dilution, whereas gentamicin and tobramycin's enterobacterials breakpoint has been reduced to 1 dilution breakpoint, and that is matching their now ECOPs. So and for amikacin, in case of Pseudomonas aeruginosa, there is no change in breakpoint for susceptibility, but it has been changed to urine isolates only. Now I would again hand over the stage to Sumit sir to carry forward the next presentation.
Thank you, Dr. Dev. That was a very exhaustive explanation of why the aminoglycosides breakpoints have been changed. One major issue that's going to come is going to be with the commercial AST manufacturers, because there is a particular slide we have not shared for reasons that some commercial AST systems will not be able to detect lower MICs of 4 or 2, because some commercial AST systems are detecting the projected MICs, some are detecting the absolute MICs. So especially the ones who are detecting the absolute MICs, which ideally is a better system, will not be able to detect a lower limit of the MICs that has been reduced from 16 to 4 or from 8 to 2 or from 4 to 2. So those lower levels will not be detected by certain commercial AC systems. So that is why this particular change in the aminoglycoside MICs is going to have a huge impact even on the industry also. So is the M33 document absolutely perfect? No. There are many oddities, I would say, not exactly flaws, but oddities. Like for example, they have included vancomycin in tier 1 for their staphylococcus, which is in table 1H, and it appears to defy the very purpose of our Cascade reporting, because we will be putting vancomycin in every staph, the suspected staph, and what one might suspect is that you are supposed to report vancomycin even for MSSA, which is not the fact. But as the answer given by CLSI is because since the number of MRSA isolate has risen, so we put up vancomycin in tier 1, but we don't report it. So presence of vancomycin in tier 1 does not mean that it has to be reported. It has to be cascaded, especially in case of MSSA. So we have to cascade the report, and considering high MRSA, so that is why vancomycin was included in tier 1. So the first look when we saw tier 1 was why vancomycin is in tier 1, so it should be in tier 2. No, it is, the reason is only being this, it has to be put for in all the panels, a must put up drug, and we have to report by cascading only. Then the non-inclusion of teicoplanin for staphylococcus. If you see the table 1H in staph, we don't see teicoplanin anywhere, and it is still mentioned under the investigational category, despite the fact that teicoplanin, in my personal view and the presence of so many numerous publications, it's a much superior drug because it's got much lesser and lower nephrotoxic potential than vancomycin. It has got once daily dosing and equal or probably better therapeutic efficacy, and it has got a against vancomycin, it has got much more vancomycin, which has got a high nephrotoxic potential, skin rashes, Redman syndrome, and multiple things. One of the main problems is that teicoplanin is not present in the US, so probably that's one of the reasons why CLSI is not favoring, or it's not tilted towards teicoplanin and still tilts towards vancomycin. Again, oddity is the absence of chloramphenicol and pfloxacin in table 1B for salmonella, because chloramphenicol, ampicillin, and cotrimoxazole are three drugs that we have to check to classify a typhoidal salmonella as MDR or not. Classically, it is absent in table 1B for Salmonella shigella, and pfloxacin is also missing, which is the surrogate marker for fluoroquinolone resistance, because it is able to detect practically all the resistance mechanisms for fluoroquinolones. Few more examples are the presence of the second generation cephalosporins, that's the 2GC, are placed in tier 2, and third generation cephalosporin is placed in tier 1 among Enterobacterales. So that's one again odd placement. Meropenem is placed in tier 2 in Acinetobacter, which was earlier in the category A. That's right now is tier 1 in 2022. So Meropenem shifted to tier 2. Penicillin is in tier 2. That means test routinely but cascade reporting staphylococcus. So that is also a very odd thing that as we can see, there's no difference, like we mentioned point number 4 before also, there's no difference in the infusion times in piperacillin tazobactam for an MIC of 6. Ideally, I'm again saying the same thing again, for an MIC of 16, which is the same as the SDD of Enterobacterales, we should have 4.5 gram every 6 hourly with a 3-hour infusion, and 4.5 gram every 8 hourly with a 4-hour infusion. So that is a mandatory thing that we need to do. Comment number 13, Pseudomonas aeruginosa, also says that tobramycin does not predict the susceptibility of gentamicin. Now this statement itself is irrelevant, like Dr. Devrath already said, that now gentamicin is considered to be resistant to Pseudomonas aeruginosa, because as detected by evidence that at least 8 they have the ECOF values, the upper ECOF values for gentamicin are 8, and to kill or to have a stasis for that 8 microgram per ml, you need to have very high dose of gentamicin, which are going to be toxic. So we just can't give gentamicin for Pseudomonas aeruginosa. So that's why this statement is moot. It does not stand any value at this moment. So some other changes which are in the M33 are in Enterobacterales. They have specifically said while testing fecal isolates of Salmonella and Shigella, report only ampicillin among the beta-lactam drugs as it is more effective and amoxi may have poor efficacy compared to ampicillin. Cefidericol is has been repeated in all the different tables in table 2 to Enterobacteriales and Pseudomonas and everything, that the accuracy is strongly dependent on the iron concentration in the media, especially in the MIC determination. Whereas for this diffusion, nothing needs to be done because iron is thought to be sequestered in the MHA. So that's why cefidericol MICs by broth microdilution is likely to get lot of errors depending on what batch is it and what amount of iron concentration is there. Then again, E. coli 80cc 24922, the MIC QC range for piptazo has been revised, but the MIC QC range has been revised, but the diffusion QC ranges remain the same. So that is something very odd, that the QC ranges for MIC are reduced, but the QC ranges for diffusion remain the same. 80cc Klebsiella pneumoniae, that's 7000603, that is for I think ESBL, that is for distribution. They say that this particular strain has normally got two different colony variants, which is opaque, cream colored, and the translucent colors. So CLSI says that there are two different morphotypes of this particular 80cc strain, and both can be used for quality control. Now this is very important. That's a direct positive blood cultures for AST for Enterobacteriales. Ampicillin breakpoints are added for the early reading, that is 8 to 10 hours early reading. They have added ampicillin breakpoints, while meropenem and ciprofloxacin are added both for the early as well as the standard reading times. That is, mero and cipro are added both for 8 hours and for the 16 hours readings. Now, what does the future hold for M100, especially in the year 2024? One, as you can see, already been told by Dr. Devra that we are going to have gentamicin added in Pseudomonas aeruginosa in your appendix B, that's our intrinsic resistances, and ceftazidime will be added for Stenotrophonas multifilia in appendix B. The way we have had separate table 1B separate from table 1A of Enterobacteriales, Salmonella and Shigella to next year, most likely there we may have a separate table number 2. So table number 2 is basically the susceptibility testing interpretive criteria, or the, when you say when this is under this MIC, what is the breakpoint interpretation? So that may also be different for Salmonella and Shigella next year. So that's also likely to add one table, table 2, separate table 2 will be added for Salmonella and Shigella. Similarly, there might be revision of Amikacin doses for Enterobacteriales or Pseudomonas aeruginosa, both in table 2, because this year they have lowered the MICs, but maybe later on they might have to increase the dosages, because like this moment the breakpoints of CLSI and UCAS may match, but the doses are not matching. So they might increase the doses from 15 mg per kg body weight OD to maybe 25 to 30 mg per kg OD next year onwards. Then again, like Dr. Devra already said, specifically not to use aminoglycoside with current doses of monotherapy, and to use only in combination with a synergistic drug with different site of action, possibly a cell wall agent. So, except for few rare cases of uncomplicated UTIs where in the urine, as you can see, there will be one question there, because there is a I caret symbol is always there for tobramycin and nettlemycin. So because they are concentrating in the urine, so that is why, except for certain uncomplicated cases of UTI, aminoglycosides have got no role as monotherapy. They are to be given only as combination therapy. Next year there might be a revision of the piperacillin tazobactam disc contents, and the breakpoint zones may be brought into action. CLSI may also recommend a method for AMC Beta-Lactamases, and even add a separate table 1 subcategory for the Hechias, that is organisms that is the inducible or the chromosomal AMC Beta-Lactamases with cefepime in tier 1. Right now, cefepime is under tier 2 in Enterobacteriales. So for the Hechias organisms, they might add cefepime, and they might remove the third generation cephalosporins in the entire list in the table 1 if they have a separate table for the aqueous organisms. And of course, the possibility to include nitrofurantoin in the intrinsic resistance for all the urease positive GNPs. So in the urease positive GNPs, since they will increase the pH, they will make the urine alkaline, which nitrofurantoin cannot act. So it is not possible that Klebsiella may have nitrofurantoin as intrinsic resistance. And since we are adding only Morganelli as in the intrinsic resistance, we might start adding Klebsiella also. And of course, addition of more antibacterials to the direct distribution testing from blood is expected. So other than meropenem, ciprofloxacin, we might have more antibiotics. Astronam, avibactam, and ceftazidime, avibactam, and astronam brought this test protocol shall be introduced. So they're probably introducing a disc elution test for ceftazidime, astronam, and something like this we are doing in a commercial AC system in our setup also. And certain questions. So at the end of this particular CLSI webinar, we had some very interesting questions which are answered by CLSI. For example, this question which is asked by many people invariably in most of the forums also, since Pseudomonas aeruginosa has a chromosomal inducible AMC, why is it okay to report ceftaroline when it is susceptible? So we always get a D zone whenever you're putting imipenem in the center surrounded by ceftaroline, piperacin, tazobactam, or astronam, you always get an inducible D zone, that is the chromosomal AMC, which is intrinsically present in the Pseudomonas aeruginosa. So what the CLSI say is that the risk of derepression, like we see the very common derepression happening in the aqueous organisms, that derepression of Pseudomonas, that is Pseudomonal AMC, is not high as compared to the aqueous organisms, that is the chromosomal AMC beta-lactamase. So ceftaroline was specifically designed for the activity of this PDC or the Pseudomonas or the Pseudomonal AMC beta-lactamase aeruginosa. So there is no risk of any kind of derepression. So we can still safely give ceftaroline for Pseudomonas aeruginosa, even there is a D zone formation, and that indicates the chromosomal induction of the chromosomal AMC beta-lactamase. So again, same thing, since Klebsiella pneumoniae is also urease positive organism, why is it not made intrinsically resistant? So what the CLSI says that they will forward this to the intrinsic resistance ad hoc working group, and probably they might add all the urease positive organisms in the intrinsic resistance list, and nitrofurantoin may be included in all the urease positive organisms as the intrinsic resistance bar. Again, why azithromycin is reporting restricted to Salmonella typhi and Shigella? Because these are both intracellular organisms, and azithromycin only, not all macrolides, only azithromycin does not penetrate the gram-negative cell wall very well, but azithromycin concentrates inside the WBCs, and this allows the drug to be active against Salmonella Shigella, but not for gram-negative bacteria that are not intracellular. So that means it acts primarily on the intracellular gram-negative bacteria, which are the Salmonella and Shigella, and not on the extracellular bacteria very well. So that is why it has got a good efficacy. However, there might be a creeping MIC or increasing MIC of azithromycin, especially in India. So we have to be a little bit careful and look at the resistance patterns of azithromycin in India. Then, when will cephalosporin-sulbactam breakpoint will see the light of the day? So just for your information, I can give an open challenge. Anybody can share what are the susceptibility testing interpretive criteria for cephalosporin-sulbactam, because US FDA, UCAST, US CAST, any other international statutory body does not give any clinical breakpoints or interpretive criteria for cephalosporin-sulbactam, and these are, like I said before, these are specifically present in India specific cards only, because the reason given by CLSI is the drug sponsor, that is Pfizer in this case, has not brought any request to CLSI and it has not been reviewed. And we will bring this to the attention of the CLSI Breakpoint Working Group. This is the CLSI response. And because CFS is available in two different formulations, one is a 1:1 ratio and one is a 2:1 ratio, for which the breakpoints are going to be different, and from both the cases the breakpoints have not been evaluated. So are there urinary breakpoints for gentamicin and tobramycin? Like Dr. Abrams said, because the aminoglycosides are concentrating very well in the urine, so therefore for the enterobacterialis, the intermediate category is given with the I caret symbol for tobramycin and gentamicin and amikacin. This indicates that with the MICs or distribution zones in this range, despite being in the intermediate range, they might still be considered as susceptible for isolate from the UTI, right? So the take-home message is that we all have to read, study, imbibe, discuss, deliberate as much as possible the M100 document, the 33rd edition, because it has got a lot of changes over here. The tiers which have been made, tier 1, 2, 3, 4, are meant to create the antibiotic panels. They are guidance tools, they are not the rules. If you want to exclude an antibiotic, it's your choice, you can exclude it. We have to trash the concept of first line and second line. There is no concept of first line, second line. You test for 20, 30, 40 antibiotics, but do only cascade and selective reporting. Very carefully report few antibiotics, but maintain the data for your antibiogram also. Be very careful with aminoglycoside and peptazole for enterobacterialis and Pseudomonas aeruginosa, which has been explicitly explained by both the speakers. Do not report Gentamicin, Pseudomonas, and do not interpolate or interpret Tobramycin susceptibility in Pseudomonas to be Gentamicin susceptible as well, like cautioned by Dr. Dev. Or don't report third generation cephalosporins for the heck organisms, even if susceptible. With that, we like to thank you so much. Please like, share, subscribe and comment on this particular video, and please subscribe to our channel, and we'll be loading as many videos on maybe later on next session we might upload some videos on the detailed aspects of the Q&A sections of our CLSI webinars. Thank you so much.